Well, welcome everyone. Welcome to this evening's Food for Thought public lecture. The theme of the lecture series this semester is the Food-Water-Energy Nexus, Dignified Lives for Billions on a Finite Planet. I'm Grant Clark, Associate Professor in the Department of Bioresource Engineering, and one of the organizers of the Food for Thought series, together with Anna Duff and Anne-Sophie Caron. I'd like to begin with our land acknowledgement. I'm the descendant of Northern European settlers, and I live and work on unceded Indigenous territory. The Kanien'kehá:ka Nation are the custodians of Tiohtià:ke, the territory on which McGill University stands, and of the surrounding lands and rivers. To the south of Montreal is the community of Kahnawake, and to the west is the community of Kanesatake. I thank these people for having watched over these lands and waters for so long, and for continuing to look after them today. So a bit of housekeeping. I'll ask our viewers online to keep your audio muted during the lecture, and I'll monitor the chat window and will relay questions to the speaker if you wish to ask them that way. During the question and answer period, you can unmute yourself and you can ask your questions verbally, and we will hear you over the speakers in the classroom. So it is my pleasure this evening to introduce Dr. Mary Doidge. She's an assistant professor of agricultural economics. She holds her BA, BSc, and MSc from Guelph and a PhD from Michigan State University, and followed that with postdoctoral work at Ohio State. Professor Doidge's research examines farmer decision-making in the context of land use, crop insurance, conservation, and climate change adaptation behavior. She's interested in farmers' on-farm economic decisions in the face of risk and uncertainty, and how insights from other social sciences can be applied to the study of agricultural economics. So again, with pleasure, I introduce Dr. Mary Doidge.
Thank you very much, Grant, and thank you everybody for coming today. The title of my talk, what I'm going to talk about, is agricultural decisions at this food, energy, and water nexus. Thinking about the consequences of these decisions, the challenges that they pose in how we can influence these decisions, and potential opportunities in this space as well. As Grant said, I am an agricultural economist, so this is the way I approach these decisions. I look at how farmers make decisions for their farm in terms of their crop insurance and under other risky scenarios, and also how farmers make conservation and adaptation decisions on their farm as well. So looking at the changes that they make to their operations in the face of these potentially risky scenarios. And I'm interested in this, and I haven't examined it really why. I've been interested in this for a while. I haven't grown up on a farm, but a lot of my life was spent adjacent to agriculture. But thinking more about why I'm interested in these particular decisions, and for me, it stems back to where I grew up. I'm from Ontario. I'm from the Bruce Peninsula in Ontario. I'm not sure if any of you are familiar with this area. It's a very small community, pinpointed on the map there, right at that point there. Montreal is over here. It's about 8 hours away. It's about 4 hours north of Toronto. Not quite in the middle, but right, looks fairly close to the center of the Great Lakes there. If you have heard of it, it's probably because of pictures like this. Georgian Bay is the water here. I actually took these two pictures on various hikes that I've taken. This one I can't claim, but the deep blue waters of Georgian Bay, these striking limestone cliffs, lots of forest land. And if you do know it, you probably know it because of its natural beauty, because of its tourism, and the national parks represent a really important part of the economy in that area. But another really important part of the economy is also the agricultural production on the Bruce Peninsula. A lot of corn and soybean is produced. This is a canola field. It's also known for its livestock production. A lot of beef cattle are produced up there. And this picture here shows this is part of Georgian Bay right here. I don't know if you can see my cursor. Part of Georgian Bay, but right up against that agricultural land. And farming is also a really big part of the community, a really big part of the economy on the Bruce Peninsula. And more recently, it's being used to generate energy. There are only a few of them so far, but because of its position between those two great big bodies of water, it can get kind of windy, and people are now starting to explore the potential for this area to produce natural energy, wind energy as well. And to me, this little cosm where I grew up really exemplifies what we mean by this food, energy, water nexus. Thinking about how the energy that we use and also produce, the resources that go into agriculture, but also the food that is produced from agriculture, the use of water in agriculture, and also the consequences of agriculture for water, all exemplified in this area. So in addition to the ways that the land on the peninsula is being used for energy, farmland can also be used to produce crops for biofuels, that food versus fuel question, used for solar production, and more land is being used for solar production in some areas. But again, just looking at the nexus of these three resources and how they go together. And like I said at the beginning, in particular, how agricultural land is used for these three uses and how they come into conflict sometimes. So again, thinking about the resources and the energy and the water that we use as inputs into the agricultural land, and also the outputs from that agricultural land in terms of energy production, in terms of food production, and in terms of not water production necessarily, but water quality impacts of the way that we use this land and of the decisions that farmers make on their land. This is important to that particular area. Agricultural production is also important for Canada. It represents a fairly small portion of our country's GDP, but in terms of raw numbers, it's over $30 billion. And this was the most recent agricultural census. So in 2016, and agriculture and the wider agri-food industry represents about 7% of Canada's GDP. So it does represent a significant portion, and it's especially important for a lot of smaller rural communities. It's important for the country as a whole, but for the survival of these communities, agriculture is a really important economic sector. The agricultural production in Canada has been increasing. It's dominated by grains and oilseeds, things like corn, soybeans, canola, wheat in the prairies. It obviously changes geographically, but also livestock production and dairy production and other uses of land that have consequences for the environmental quality as well. Like I said, Canada is a top producer of some crops like canola. A lot of it is exported. We're also a significant producer of oats, wheat, soybean, and barley. And this makes up a lot of the really important part of the agricultural economy in Canada. In Canada, it's not that deforestation isn't an issue. It's not as big of an issue as it is in other places. But when we do see conversion of land between these uses, between forest, between urban land, and between agricultural land, the net conversion is into agricultural land. We see some land being converted from forests, some land being converted from farmland to urban land, but the bulk of the land conversion is from forest land into agricultural land. So taking away some of this natural capital that we have in forest rather, and putting it into farmland. Despite the net changes into farmland, the actual area under production in Canada has not changed all that much in the last 50 years. I can see my cursor, right? Okay, so because most of you are online, I'll indicate with the cursor here. The dark blue bars is a total farm area in Canada, and there have been some fluctuations over the years, but it's remained generally steady over the last 50 years. And a little over 6% of Canada's land is being used for agricultural production. And for comparison, a little over 1% is in urban land, and almost 40% is in forest land. So it makes up a relatively small portion of the total land area, but it is concentrated in certain areas, and especially towards the southern part of the country. But the actual amount of land under production has remained relatively constant. Despite this, we have seen significant increases in farm productivity in Canada. And this is from 1961 until 2013. Using 1961, just an index, so that's starting at 1. We can see that it's increased almost 3 times over those past 60 years. And this is just output of all of the agricultural products in Canada, livestock and grain, and fruits and vegetables and all those other smaller products. But you can see that farms have become a lot more productive in the past 60 years due to many factors, a lot of technological advancements, and other practices that farmers are using on their farm. But paired with the fact that we haven't really expanded the land under production and we're producing a lot more from the land that is under production, that means we're asking a lot more from the land that is being used to produce these agricultural products. And a lot of this increased productivity is coming from input use, is becoming from the way that we are drawing resources from the land in terms of the natural soil properties, carbon, and other things that are in the soil, and also the inputs that farmers are applying to get more out of the land. And oftentimes agricultural production is in conflict with natural resource quality. There are lots of instances we can think of where agricultural production has a negative impact on environmental quality. It also competes for energy use, for water use, for resource use. Agricultural production does produce emissions, and livestock agriculture is a good example of this, where a lot of the greenhouse gases from agriculture are coming from livestock production. And production intensity can also negatively impact the biodiversity, both in the soil and the wildlife biodiversity, insect biodiversity, all kinds of biodiversity. When we think about the energy that goes into agricultural production, this gray line here shows the agricultural or the energy intensity rather. And I think some people point to this and say that it's decreasing, and that's the energy per dollar of agricultural value that's being produced. And that is decreasing. But if we look at the overall amount, the amount of energy that's being used in agricultural production, that's been rising somewhat steadily since 1990 to 2016. And the bulk of this energy is in the form of fossil fuel production. I think the only one that might not be fossil fuels is this fairly small dark green band here, which is in electricity. But the rest represent things like diesel fuel, gasoline, natural gas, drying grains takes up a lot of energy. So the energy use in agriculture has been increasing over the years. And agriculture is also a source of greenhouse gas emissions. And again, because of its relatively, it still represents a large piece of the economy, a large piece of land use. Compared to other industries, it's relatively small, but agriculture does account for about 7% of the greenhouse gas emissions of the industrial sectors in Canada, behind other industries. But just like the energy use, and again, it's not surprising given the sources of energy, that greenhouse gases from agricultural production are still increasing. Between 1990 and 2015, the emissions from agriculture increased by 21%, and even from 2000 to 2015, that increase is smaller, but it's still, with the targets that we have for decreasing our overall greenhouse gas emissions, agriculture is still increasing the greenhouse gas emissions that it's producing. I'm going to give you some not so good news and then kind of talk about ways that we as researchers can address these issues. But another really prime example of the negative impacts that agriculture can have on the natural environment are the nutrients that are runoff that enter area waterways and can have really, really bad, almost catastrophic effects on these large bodies of water. This is Lake Erie here, and almost every summer now, Lake Erie, this is Ohio on the south and then Ontario on the north end. And almost every summer in this Western Lake Erie Basin, there are harmful algal blooms. And this is a close-up picture with the dead fish, but it really does capture the consequences of these blooms. Cyanobacteria will proliferate in this Western Lake Erie Basin because it's relatively shallow. It can get quite warm in the summertime. And there is a significant river that's running from Ohio and Indiana right into this Western Lake Erie Basin. And as the river runs into the water, into the lake in the summer, it carries a lot of nutrient runoff from agricultural production, and particularly phosphorus. But that paired with the shallow warm waters can produce these harmful algal blooms, which are bad for wildlife, bad for recreation. This is Lake Erie. They're also happening now in Lake Champlain, which is closer to Montreal. But the same sort of thing is happening, is that nutrients are entering the water, and when conditions are right in the summertime and with temperatures warming, with increased rainfall or increased significant rainfall events, more of these nutrients are entering these lakes and producing these harmful bacterial blooms. And because it's been happening so frequently in Lake Erie, there are lots of instances and lots of examples of the really negative effects that this can have. So cities along the shores of Lake Erie often rely on the lake for drinking water. And when these blooms happen, the cities have to shut down their water sources. And in Toledo, sometimes for days, the water will be shut down. So residents have to look elsewhere for drinking water. Recreation is impacted, lots of fishing charters. And this paper is looking at the effect that these blooms are having on housing prices. So the impacts of these agricultural land decisions are often felt downstream, literally and figuratively, and have lots of different environmental, economic effects that aren't necessarily linked to where it's happening. And we know that these are some examples, but agricultural practices have environmental consequences, and this is well known. And we know because of this, people are researching how we can address the sources of these pollutions. And we know that some agricultural practices can be effective in reducing these negative environmental consequences of agriculture on the natural landscape. Certain practices can reduce nutrient runoff. These are particularly effective in reducing phosphorus and nitrogen runoff. Things like planting cover crops, which is this picture here. Cover crops are things that farmers can plant after their cash crop has been harvested, and it will provide a cover over the land over the winter usually. And then that's something that farmers will plow under, and preventing some of those nutrients from running off and keeping that in the soil so that it can be used for the next year's crop production. Farmers can also use practices like injecting nutrients into the land rather than broadcasting over the surface, so that if a significant rainfall event does happen, that fertilizer isn't just going to be washed away. It will be in the land, which will make it more available to the crops, but also prevent it from entering rivers and lakes and streams. And farmers can also take pieces of land close to waterways and take it out of production and install what's called riparian buffer strips. These are trees, but they can also plant grasses and other permanent crops, or permanent plants rather, that they wouldn't harvest, that stand as kind of a filtration system, and again, filtering some of those nutrients, so to prevent them from entering rivers and lakes. In terms of greenhouse gas emissions, some of these practices can also increase soil carbon, so prevent it from being released into the atmosphere. Cover crops, again, can help with this, help reduce greenhouse gases, and also improve soil quality for the farmers, improve moisture retention, things like reduced tillage or no tillage, leaving some of that crop residue on the ground, to improve soil carbon, to prevent it from being released into the atmosphere. We know that some of these practices can have positive impacts both on the farm for individual farmers and for the broader environment. But solving these problems on a big scale is not so straightforward. With these harmful algal blooms, with greenhouse gas emissions, they're what we call non-point source pollution. And that's because the pollution can't be identified taken back to one source. In the 70s, I believe, Lake Erie was experiencing these harmful algal blooms before, but that was largely due to wastewater treatment plants and other companies dumping their water into the lake and causing these blooms. And when it was easy to pinpoint, they could put regulation in place and to stop that from happening. Now, because it's being spread out over a wide variety, a lot of people who are contributing to this problem, but them individually is not causing the problem, it's a lot harder to address these issues. There's often a disconnect between the timing of the costs and benefits, both for the farmers and for the people experiencing the negative consequences of these decisions. And farmers aren't necessarily the ones who are being harmed by their collective decisions. And again, it's not just one farmer, it is the population of the agricultural producers. But if they're making decisions 3 hours down the road about the nutrients that they're going to apply to their fields, they're not the ones whose drinking water is being turned off every summer in Toledo. So there's a disconnect between the source of the problem and who is being harmed by the problem. There is some good news. I'll get into some good news and then some opportunities for hopefully better news in the future. There is some progress on conservation practices. It's hard to find data on these practices in Canada in particular, just because there are fewer farmers, fewer researchers overall. We do see increases in the farmers who are adopting no-till or conservation tillage practices on their farm. This goes from 1991 to 2011, and the red bar are the proportion of farmers who have adopted no-till seeding. So not tilling their land, not releasing some of those emissions into the atmosphere. So we do see increases in some of these practices. We see adoption of some technologies that can allow farmers to be more accurate in their nutrient application. This is technology adoption by farm size in 2015. And we don't see this happening much among the smaller farmers or smaller farms, but among farmers who operate large operations, over 5,000 acres and over 10,000 acres, we see significant proportion of these farmers adopting these technologies. This GIS mapping, GPS, that will allow them to be more accurate, more precise in their nutrient application. So rather than applying it to the field more broadly, targeting it to where it's needed and reducing unnecessary application of some of these inputs. However, we often find in the research that it obviously varies, but the farmers who are more willing to experiment with some of these technologies, change some of their practices, incorporate some more conservation-minded activities are the ones who are younger, and the number of farmers in Canada is decreasing, and the proportion of farmers who are younger is also decreasing. So we have an aging farming population in Canada. The average age, I believe, is 56 or 57 now. And we see the proportion of farmers under 35 years. It was as high as 20% in 1991. And in 2016, it was down to 9%. So although they're more likely to be willing to adopt some of these practices, the number of farmers in that category is decreasing. So I'm interested in studying how farmers make the decisions that they do and their motivations for making the decisions that they do in terms of their conservation and adaptation decisions. And this can provide important insights into the motivations, their barriers for not adopting some of these practices, and opportunities in identifying how we might be able to promote some of these conservation decisions. And often if we study their past decisions, it will help us predict their future decisions about events that have not yet materialized. So kind of projecting if certain conditions were to occur, how can we predict farmers' behaviors or likely behaviors? Often, and even I guess among economists, but non-behavioral scientists, I don't know if I can call myself a behavioral scientist, but they say that we should just provide incentives, we should subsidize some of these behaviors, and then farmers will adopt them. So if you just pay them to plant cover crops, then they will do so. And that is sometimes true, but these decisions are a lot more complex, and a lot of other factors influence the decisions that farmers make. And in my work, I hope to bring in insights and methods from other disciplines to enrich the work that economists do, and drawing from disciplines like rural sociology, psychology, looking at how we can use the work of climate researchers, communication specialists, because sometimes it's just how we communicate with farmers, how we communicate with rural communities about the importance of some of these decisions, and public policy and public health, and providing some of the insights into farmer behavior, and like I said, how we might be able to promote the practices that will have a positive impact on the farm and for the environment, for the natural resources around us. to do this, we can use a variety of different methods to understand farmers' decision making, including focus groups and surveying farmers and using what's called economic experiments. And I'm going to make a plug here, but I think all of this is improved. We can do a lot of this and gain a lot of insights, but the quality of our work is improved when we involve end users in our research and in our research design. So working with farmers from the beginning of our projects to help inform what we should be looking at, the ways that we should be looking at, and how best to communicate with farmers, and also how we can learn from farmers as researchers about the barriers that they face, about and even sometimes the questions that we should be asking. So working with these communities from the get-go really helps improve our work. Some examples of work that I've done with farmers and I guess for farmers. We can ask them survey questions. So rather than just looking at the practices that they have adopted and trying to figure out who's most likely to adopt them just based on observational data, we can ask them more detailed questions about the specific practices that they have taken on their farm. This is just an example of a larger survey, but so we can understand about who has already done this and then who is likely to undertake some of these adaptations in the future. So how likely are you to hire more labor? How likely are you to sell your farm if conditions got bad? How likely are you to plant cover crops? So we can understand about who has done it and who has not done it, who is likely to do it, and why the barriers that they might face in implementing some of these practices. But a lot of times farmers report that they intend to adopt a practice, but when it comes time to actually doing the thing, just like everybody else, they don't always follow through. And it's not because they don't want to, it's because of the barriers that they face. And, well, that's one of them, but also other barriers, other things that are stopping them, or they might have decided that it's not worth it for them. So understanding why they don't always follow through on these intentions, and again, how we can address some of these barriers, how we can make it easier for them to adopt these practices. We can use methods like this is kind of a modified choice experiment, but presenting them with new scenarios. So trying to capture, and again, we have to simplify it a little bit, but capturing some of that, the complexity of their decision environment to understand more about the decisions that they're making. And this is an example of another survey that I've done with farmers in the United States, but looking at how they respond to changes in their land, changes in their agricultural revenue per acre, any conservation subsidies or lease payments that they might get, and compensation for installing wind turbines on their land, and how they might change their land use when they're faced with these different scenarios, these different compensation schemes. So asking them how much land they would put into commodity production, how much land they would set aside for conservation, and whether they would install any wind turbines on their farm if they were compensated this amount. And we can also do what's called economic experiments. And that's again where we have to simplify their decision environment quite a bit, but we can modify small things. We can play dice games and try to frame these experiments in their actual decision environment. And again, it's losing some of that complexity and some of the consequences of their real decisions, but it's allowing us to see how past events, how other things that we're modifying can influence their decisions. So this is an example of an experiment that I did with farmers in Michigan, looking at whether they would purchase crop insurance, not directly related to conservation behavior, but looking at they were just rolling a dice to determine the weather conditions for that year, and then based on those conditions, what are they going to do for the next year? So if it was bad, am I more likely to purchase crop insurance? So we can get at some of the mechanisms of these decisions that they're making. Sometimes what we find from these surveys is that farmers are reluctant to change their current practices because of the risks of changing. There are costs of making changes. There are costs of implementing new practices on their farm. There might be benefits. There might be benefits in the future. There might not be benefits at all, both particularly financial benefits. And when the costs are incurred, when I have to pay for it right now, and I don't know if there's going to be a benefit at all, and if there is, it's likely going to be in a few years. Farmers are often reluctant to make some of these changes on their farm. Farmers are constrained by finances, and when they're already making quite narrow margins, it's hard to incentivize some of these changes. Adoption of certain technologies is also seen as risky. They might be productivity enhancing on average, but that doesn't mean they're going to be productivity enhancing for each individual farmer. And because of that, because of that uncertainty, because of that potential risk, farmers might not be willing to take that leap to buy a big piece of equipment and adopt these technologies. A lot of on-farm adoption decisions are the result of the social environment that farmers are in, talking with neighbors, experimenting, seeing how something worked on somebody else's farm. They can maybe take a small plot of land, see if they plant cover crops over the next few years, are they going to get a higher yield there? And also the social environment influences their behavior as well. So not just learning from neighbors, but thinking about how their neighbors might think of them if they see them adopting a certain practice and how they see themselves within this farming community. Whether they want to be seen as an innovator, as somebody who's doing some new things on his or her farm, or if they think that, oh, if I do this, if I stop, or if I adopt no-till and everybody else is tilling all their fields, are they going to think that I'm doing something weird and I don't want to be seen as an outlier or somebody who's sticking out in my farming community? So this is also influencing how they're making these decisions. Farmers are I don't know if I have it on another slide. Farmers are aware of the long-term impacts of decisions. And I hope I'm not contributing to it now, but I think sometimes that farmers get a bad reputation and people think that they just want to produce on their land and they just want to make a profit. And that's obviously part of why they're farming, but a lot of them come from generational farming families working on land that has been passed down to them through their family. And they are aware of their role as stewards of the land. They want to preserve land quality for the next generation. So this is a concern. They do see their role as, like I said, stewards of the land, but the numbers of farms in Canada is decreasing. The size of the farms are increasing. Fewer and fewer farms. It's still happening. It's still being passed down to the next generation, but this is happening less and less as the farming population declines. I can say this. So like I said, they do take their role as stewards of the land seriously. And they also, just like any of us, how they see themselves influences their decision. Some work has looked at how farmers view themselves in the community, their role as farmers, whether they have a stronger conservationist identity and whether they, again, see their role as somebody who is preserving land for the next generation, who is contributing to environmental quality, who is improving biodiversity, or whether they see their role not as a conservationist, but more as a producer, somebody who should produce food, adopt the newest technology, get the highest yields possible. And some of these, and it's possible for farmers to have both of these identities as well and try to balance their role as a producer and as somebody who is enhancing environmental quality. We also have found that farmers who think that a practice is going to be more effective are more likely to adopt it. So when we're talking about those practices like subsurface placement, injecting those nutrients into the soil, or planting cover crops after their harvest, when they think that these practices are going to be effective in reducing nutrient runoff, they are more likely to adopt them. And so this just shows the relationship between efficacy at the farm level, whether they think that these practices are going to reduce nutrient runoff from their farm, whether they think these practices are going to be effective in improving water quality at the watershed level. So not just on their farm, not just on the streams locally, but also in Lake Erie and these bigger rivers, and looking at how effective they think that they can be in implementing these practices. So whether they have confidence in their own ability to effectively use these practices and to be successful. So when farmers are more confident in their own abilities, and when they think that these practices are going to have a bigger impact, they're more likely to adopt them. These are some examples of the way that I think we can use insights, use methods, use approaches from other disciplines in our work to enrich the models that we use as economists and just as researchers overall. And if we neglect some of this complexity, if we just look at how we subsidize and say, well, why aren't they adopting? We've subsidized these practices. They're foolish not to take advantage of it. If we neglect some of this complexity, we're missing significant pieces of the puzzle, and we're not fully understanding why farmers are behaving the way they do, why they're making their decisions. And when we use these models, when we use these methods and try to make predictions about how they might behave in the future, we're not going to get it right. And this becomes more important as the future becomes more and more unpredictable with climate change. So we can use these insights, we can promote conservation and address farmer-specific barriers to adoption. If one of the barriers is cost, we can subsidize, we can use subsidies. And I don't want to say that that's not effective, because it really can be. But we can also address barriers like knowledge. So if they just don't know enough about these practices, we can improve our outreach efforts. We can have more demonstration days. We can tell farmers about how to use this process, how they can be more successful if they adopt it on their farm. If they want proven effectiveness, we can, and we as researchers, not necessarily me as an economist, but provide on-farm trials and social learning and let them talk to people in the community who have used these practices so they can demonstrate how it might be used, how they might be effective in using it on their farm. And we can also use behavioral insights to frame information about the potential consequences of their decisions. So rather than just saying, if we know that losses are more motivating, we can frame these decisions, frame the consequences in terms of looking at what's lost. So rather than saying that this is having an impact on water quality, saying this is what Lake Erie used to be like, and now this is what it's like. So showing, some really vibrant ecosystems, and this is what we have had. This is what we may lose if we continue on this path with nutrient application as it is, as an example. And some tools to increase the value that farmers place on future outcomes. So making them think about their legacy as somebody who's working on the land, or even some of my work, it hasn't been published yet, but just asking farmers to think whether they might regret a decision in the future. This was looking at their land use decisions, but looking at whether they might regret an economic decision and how we can use that to promote decisions that might also be able to enhance the environmental quality of the ecosystem services provided by that land. This is, like I said, becoming particularly concerning as the climate is changing and as the agricultural landscape is changing due to climate change. Climate change might provide some opportunities for farmers, in some areas, and especially in Canada, if the climate warms, we might be able to produce more. We would have longer seasons, warmer temperatures, different crops that we can produce. But largely the effects are expected to be negative. So with those temperature changes come new pest threats, more frequent and more severe precipitation events, large rainfall events, flooding. It can cause crop damage, and more variability in the weather introduces a new source of risk for producers. Farmers are very aware that the climate is changing. They're seeing it firsthand. And again, most of my work has been in the States, where it's a little bit more political about the causes of climate change, but even farmers there, even in rural Ohio, they might not agree about the causes of climate change, but they know that the climate is changing. And they know that some adaptation is necessary, if not now, in the near future. And recent climate events, to me, demonstrate, going back to that food-energy-water nexus, how closely agricultural land is tied to energy, is tied to the consequences of their decision, and just kind of making that link really strong for farmers and for us as a society, I think. These are just some news examples from last year with all of the droughts and the flooding simultaneously, and in Quebec, just thinking about how farmers are starting to think about adapting their operations to climate change. There has not been a whole lot of work among farmers in Canada, but anecdotally, we know that farmers are experimenting with newer varieties that are suited to different conditions, that can withstand higher temperatures, that can withstand drier conditions. But these are varieties that aren't typically grown in Canada. So again, they do present some risks to farmers. We know that farmers are reacting to, well, in general, we know that farmers react to these events. Experimental evidence like that experiment I showed you with crop insurance shows that farmers are more likely to purchase insurance when they experience a loss in that experiment. And these experimental results are confirmed by looking at actual crop insurance purchases. So that we observed, and this is a colleague, I wasn't involved in this research, but they looked at national data in the United States, and after significant weather events or a season of significant weather events, farmers were more likely to purchase crop insurance. So they are responding to these events. These are financial tools that they can use, but there are other ways that they haven't been adapting. However, the adaptations that they're taking on their farm have been largely incremental. So they're not making big sweeping changes, but they are changing the varieties of the crops that they grow, altering the dates that they plant and harvest due to the variable weather conditions, purchasing insurance, like I said, investing in equipment that will reduce the time it takes to perform some of these activities so that they, if they only have a small window to plant, they can get it done if they have the proper equipment. There are also adaptations they can take in response to climate change, but that are going to have environmental improvements on their land. And that some of these changes will make their operations more resilient to climate change in the future. Things like planting cover crops to retain soil moisture, to improve CO2 in the soil. More widespread use of reduced tillage and no-till systems to improve the soil quality while helping reduce moisture and heat variability. But unfortunately, these are very complex problems, and they're not going to be solved with simple solutions. So by combining the insights from these other disciplines, we can more accurately, or we can understand better the decisions that farmers are making and the barriers that they face. Unfortunately, these are expensive, both in terms of the money it takes to conduct this research and the time it takes to collect these data to, it's easy, well, it's not easy, but it's easier to just go and do a survey than it is to involve farmers in your survey design, talking to farmers, to getting feedback and making sure that we're asking the right questions. It just takes longer. It makes the work better, obviously, but it just takes a much longer time. So involving farmers and other stakeholders will make our work more applicable to the situations that farmers are actually facing. They know about the adaptations, they know about the opportunities that they have, and they're facing real barriers and opportunities that we might not know as researchers. We do know that producers respond to incentives sometimes the way that we think they do. When they have incentives to adopt, or they don't have incentives to adopt, they're less likely to do so. And I know I'm running out of time, so I'm just going to go through finishing up here in a second. And we do know that, farmers think they're kind of in this position too, where they're feeling the consequences of the environment, and especially in terms of climate change. They're contributing to environmental quality, both positively and negatively, but they're also business people. They're running businesses, and they're facing small or quite slim profit margins. And these decisions, or these barriers that they face, these financial constraints, are important in thinking about how they make these decisions. And often they will plant what is more profitable because of these small margins. So rather than producing perennial crops like alfalfa, they will plant corn and soybeans if that is what is going to make them more money, because they have these small profit margins. And I do also think too that we're looking, what I presented here, and I think it's very important to understand how farmers make these decisions, but I don't think it should be presented as the only solution to these problems. These are individual solutions to a systemic problem. And farmers faced with those financial constraints are caught between sectors with increasing market power. So there's concentration in the input industry, there's concentration in the processing and the food retailers, and farmers are kind of caught in there. So again, changing those financial constraints that they face. And individual decisions are very important to understand, how we can promote particular activities, but I don't think they're enough to fully address these issues, to fully address the problem, and this problem of how we manage land use, water use at this food, energy, water nexus. The policies put in place by federal and provincial governments also have a big impact. This is just an example from Ontario, but the government in Ontario taking out a big piece of the greenbelt, that changes the incentives that farmers face. And I don't think we can just look at individual decision makers to solve this societal problem. But I still think it's important to recognize the role that farmers play, and so we can support them in their conservation activities. We can encourage adoption of practices that enhance the economic and environmental health of farmers, and provide opportunities for innovation and adaptation at the individual as well as the institutional level. Thank you very much. I apologize for rushing at the end.
Thank you very much, Mary. I'm just going to come up here and join you at the
Okay,
podium.
yeah.
And I'm going to turn off the screen share so we can all see one another a little better. There we go. And so I have a few questions to ask Mary, but at this point, some of you online may have guessed that Mary and I are alone in the auditorium this evening because of the snow. So if anybody has any questions at all, I invite you to turn on your microphone and you can ask your questions out loud and we'll be able to hear you over the speakers here. So you're welcome to do that if you like. You can also type your questions into the chat window if you like, and we can read them from there. So yes, go ahead.
Brent, this is Shiv. I enjoyed Mary's presentation very much, very informative. And I'm just wondering, Mary, if you have any like good case studies that one could kind of go through and see how farmers or different stakeholders got involved and what kind of was the end result. Thank you.
In terms of the conservation decisions or adaptation?
In terms of, like getting them involved and then asking them, like maybe in the US, like is there something that we could see how this was actually handled and what was the end result of that?
I can't think of any papers offhand. I do think that some of this work it's being done more in the US just because there are more researchers, there are more farmers that they can draw from. I've been very lucky to be involved in 2 projects when I was a postdoc at the Ohio State University, who were these big multidisciplinary projects, and they involved stakeholders. We had, it takes a lot of organization, but involving industry partners, involving energy, people who are in the energy industry, involving individual farmers, involving suppliers, and thinking about how we can promote some of these decisions. We can learn from them about the barriers that they face, and how we can facilitate this research and how we can promote these decisions that will achieve the aims that everybody wants. And again, it's not like farmers don't want to improve environmental quality. It's not like they're trying to pollute, but there's just a misalignment of incentives, I think. So in terms, I don't have a good answer to your question, but yes, I do think it's important.
Yeah, thank you again. It was very interesting.
Thank you, Shiv. Are there any other questions? Well, okay.
There's the one in the chat.
Oh, perfect. Okay.
So I think everybody can see it. So in terms of criteria, geographical scope, the surveys that I've been involved with, and again, it's unfortunate because a lot of this infrastructure, it just exists more in the States. So we were able to purchase contact information for farmers from a company that just they collect farmer information and they can sell you a list of 5,000 farmers. So, so we did a lot of mail surveys because responses are higher for that. We think we sent for one of them, I know, is about 5,000 surveys, and I think the response rate a little less than 20%, which means we got almost 1,000 responses, which is great. Which just so far here, I haven't been able to achieve anywhere near that. But it includes mail out surveys. We've done some online surveys, a combination of both, which is good. You can start with the online, see who doesn't respond, and then send them a paper survey that they will, with a return envelope, which really helps response rates. Some of the ways I've got in touch with farmers, I would visit meetings in the winter if I wanted them to do my experiments. So I would go and I went all over Iowa one week, just kind of going from farmer meeting to farmer meeting, getting them to do my surveys and experiments. So yeah, I think it's important. And it's important to meet them where they are. And obviously timing is important. They're not going to answer a survey in October because they're busy harvesting. So just keeping those things in mind.
Mm-hmm. Great, thank you. Shiv, did you have another question?
Yes. Thank you for taking my question. I was involved with a University of Guelph group, and they were basically trying to again get the stakeholders, producers involved. And what we found was the producers are very reluctant to be involved in the projects because they don't want to be known in the community that that their farm is the one which is polluting. And so I think we got a lot of resistance from the producer side to even get them talk to us and come to it. So I was just wondering if you have seen that or what are your views on that?
Yeah, I don't know about that in particular. In some of the survey work I've done in Ohio, we asked them about how concerned they were with various environmental things, but also with how concerned they were with new regulations being imposed. And sometimes that was a motivation. So I'm going to adopt these practices because I know if I don't, they're going to regulate me and I don't want to be regulated. So I will try to jump the gun and make it so that this isn't a big of a problem. Well, what I was going to say too, that I think sometimes like if farmers are a heavily surveyed population because of all the reporting that they have to do, and especially in the United States for their, crop insurance and the agricultural census and agricultural surveys. So sometimes they get another survey in the mail and they don't want to answer it, or they think that they already have because they get confused about, is this a government survey? Is this a university survey? Who is asking me these questions? Why are they asking me these questions? So they get sick of it.
Thank you.
And there's a question from Yu Jiang.
The future trend of producing greenhouse gas. Technology, that's smarter people than me can answer these questions. I don't know. I think, I don't know. I think a lot of these practices can help with reducing greenhouse gas emissions. And this, again, it suffers from that collective problem. It's not one person who's contributing to greenhouse gas emissions. It's the industry and us as a society. And I know that it didn't include it here, but in the farming community, there's a lot of opposition to the carbon tax because it's going to increase the cost of doing business. So again, it's not that they don't want to reduce their emissions, but I think we have to look at individual behavior, but also look at ways that society can reduce greenhouse gas emissions. So whether it's a carbon tax, whether it's renewable energy, and it's not going to be addressed by an individual decision.
Yeah, I had similar questions when I saw the graph about energy use. And I remember a quote from a professor emeritus, who probably passed on now, from Colorado State. And he said, modern agriculture is a means of transforming petroleum into food.
Yeah.
And that's a big conundrum because you need that energy density in order to make the modern agricultural machine work. I did have one question though, and this is probably a question that people who work in social sciences get asked all the time, because you were talking about surveys and using sort of games like dice and so on as a means of investigating people's behavior and the potential decisions they might make. How can you judge as a researcher whether or not those sorts of tools are going to actually accurately give you a picture of what they might decide in real life?
That's a very good question. And it does suffer from that external validity problem. So what I try to do when I do these experiments is to, and it's not perfect, but to frame it in their decision context. So, because some economic experiments are just removed from any context. So just playing this dice game, oh, you're averse to risk. That means that you're unlikely to adopt this practice on your farm. It's simplified, but, and I think it's better to frame it in their decision context. So saying, this is your farm, you are making decisions, would you buy crop insurance? It's removed from their actual decision, but I hope it gets a little bit closer to how they actually behave. And when this is in the North and South Dakota, we're saying, to approach these decisions like you would on your farm. And again, it's not going to be perfect, but we provide the context that hopefully will get them in that frame of mind and thinking about how they would actually respond. And then to me, I think it's important to compare it to observational data. So not using either one exclusively, but combining them. So when I talked about those crop insurance decisions, my experimental work was backed up by the observational data. So they can look at if there was a big drought in 2012, 2013, people buy a lot more crop insurance. So it kind of mirrors what we found in our experimental work.
Okay, great, thank you. And so we have another question here from Charles. What's a rough price of crop insurance per acre or per hectare?
This is awful. I don't know. And it's so much harder to find information on crop insurance in Canada than the US. Because in the US it's administered federally and here it's administered provincially.
Mhm.
So I don't know. I'm so sorry.
I imagine it probably varies a lot.
Yeah,
Too, right?
it
From
will, yeah.
region to region.
Region to region, they can choose different coverage levels, they can choose different price coverage levels. So, and the crops themselves that they're insuring are going to influence the price of crop insurance. But I'm so sorry, I don't know.
All right, so we're at the top of the hour now, but we'll entertain another question if anybody has one.
Grant, I just have one last one, if it is. Mary, your focus was mostly on agricultural production, but I remember reading somewhere that actually the livestock operations, intensive livestock operations, are actually a major source of greenhouse gas emissions. And I'm just wondering if you have looked at that, or your focus basically was mostly on agricultural production.
It's been mostly on crop production. Potentially I've got some irons in the fire, hopefully that I can expand into livestock producers as well. But so far just crop production. But to me, I think the same principles apply in terms of risk aversion. A lot of the constraints that they face, again, they're not going to be exactly the same, but the institutional constraints that they face are going to be similar. And that the same problem of it's not any one individual farmer, it's the industry as a whole. And part of the problem is consumers too, and I didn't get into that, but some of my work is looking at how we can influence consumer decision making. And farmers respond to the market. If people are going to buy beef that's from a feedlot, they will produce beef from a feedlot.
Thank you.
Great. Okay, well, thank you very much, Mary, for taking the time to share your expertise with us tonight.
You're very welcome. Thank you everyone for
Yeah,
coming.
Yes, thank you for joining us today online. It's a shame the weather didn't allow our in-person audience to come. But just a reminder that all of these talks are recorded. So if you or an acquaintance wants to view them later on, you'll be able to find them on the Food for Thought website. And I do want to encourage you and everybody you know to join us again, either in person or online in 2 weeks. And we'll have the last lecture in the series for this fall. So Dr. Brittany Jock will join us, and she'll talk about food, environment, health, and nutrition for First Nations children. So thanks once again for joining us, and have a good evening, everybody.
Thank you.